All right, and here we are in section 4.1, bottom of page 2. And let's talk now about what it means to be a solution to a linear equation in two variables. Okay, so in two variables means that you have both x and y in the equation, which means that our solution is going to be a pair of answers. In fact, it's going to be a solution is the pair of x and y that works in the equation. Or another way to say it is it makes it true. Okay, it's the pair that makes it true. It's the pair x and y. And they are an ordered pair, they go together. Another way that you'll hear talked about is a solution to the linear equation is when the x value is what you put into the equation. You put x in and you will get that y value out. That is typical for the slope-intercept form. If we were to plug in an x here, multiply it by the number for m, add the number for b, you'll get your y value out. It's like an input and an output. Some of you maybe learned about function machines, and we'll talk about functions and function notation in Math 65. But that's another way to think about what does it mean to be a solution to the linear equation. If you put an x value in here and perform the operations on it of multiplying by m, adding b, you'd get your y value out of that. Okay. Here's the key piece. When there was one variable, we had one answer. Either it was a single number, or it was a false statement that gave you no solution, or it was a true statement that gave you all real numbers. Everything works. Okay? With two variables, your solution, your set of solutions, is a line. Your set of all solutions that work in the equation creates a line. And because a line goes on forever, it might go this direction, it might go straight across, it might go straight up and down. Because a line goes on forever, that means there's an infinite number of solutions. It's not all real numbers, but there is an infinite amount because anything on that line would be a solution to this equation. So there's an infinite number of solutions to the equation. So we're going to start, which is why we want to be able to graph the line, because now we could no longer list all the possible solutions. But a graph can represent an infinite number by showing the line and then showing that it goes forever in both directions. Similarly, the equation represents that line and it represents all the possible solutions. However, where we're going to start is with questions that look like this. Determine if the ordered pair is a solution to the given equation. So we're going to start first with being given an equation and some solutions to try. So we're being given a linear equation. In this case, we're being given it to in y equals mx plus b. So the b and the mx are just switched here. They might give it to you in standard form. They might even give it to you in point slope form. I'm seeing that there is a typo here on the one right below it, so I want to catch that right away here on the try problem. Sorry, I'm pausing here for just a minute because I'm making a note for myself. But anyway, so we're going to start with this equation, and we're going to see if the given solutions, the given points, the given ordered pairs are solutions to this equation. So here we are. Okay, so given a linear equation and some possible solutions, we're seeing if any plug in and work. Okay, that's what we're being asked to do here. So we start with y equals 8 minus 4x, and you're going to take 8, 0, plug in 8 for x, 0 for y, and see if it makes the equation true. Then you do the same thing for 16, negative 2, and then the same thing again for the point 3, negative 4. So let's look at this first one here. We're looking at 8, 0. 8 is x, 0 is y. I've got the equation y equals 8 minus 4 times x. Okay? So I'm going to put in 8 for your x and 0 for your y. So it's y equals 8 minus 4 times x. So instead of y, I'm going to put in 0. And instead of x, I'm going to put in 8. And I'm going to see if this makes a true statement here. So I've got 0 on the left. I'm checking to see if this also equals 0. 8 minus 4 times 8 is going to be 8 minus 32, which is negative 24. And this is not a true statement. So this is no, not a solution. So 8, 0 is not a solution to this equation. It is not on the line that is drawn by this equation. Okay? Let's try this next one, 16, negative 2. Again, 16 is your x value, negative 2 is your y value. You're going to try to plug these in and see if it works. So here's my equation again. I've got 16, negative 2 is the ordered pair that I'm going to try in it. The equation is y is equal to 8 minus 4x. Notice I'm taking the time to write this all out and not trying to do too much in my head here, okay? So 16 is x, negative 2 is y. My equation is y equals 8 minus 4x. So I'm going to plug in 16 for x and negative 2 for y. I'm going to see if this works. And I've got negative 2 on the left, and I've got 8 minus 4 times 16. That's going to be 8 minus 64. That's going to be negative 2 and negative 56. Those are not equal, so no, this is not a solution. And our last one that we get to try is 3, negative 4. Again, there's our x and our y here. So we've got y equals 8 minus 4 times x. There's our y value and our x value. So our y value is negative 4. Our x value is 3, and I'm going to see if this works here. So I've got negative 4 and 8 minus 12. I have negative 4 equals negative 4. This is a true statement. Okay, so this was a false statement. And because we were just plugging in one solution, it tells me that that solution is no, it does not work. Okay. This is a false result or a false statement, so no, 16, negative 2 is not a solution. But this one is a true statement, so that means that yes, 3, negative 4 is a solution, not the only solution, but it's a solution to this linear equation. It is a point on the line that's described by this equation. The point 3, negative 4 on the graph, 1, 2, 3, 1, 2, 3, 4, over 3, down 4, is somewhere on this line. Now we don't know anything else about this line yet. We would need a second point to then to connect the dots and create the line that shows all the possible solutions for this. Okay? So again, it's not our desire right now. Right now we're just working our way there through some of the basics. We're just determining if the given ordered pair is a solution of the given equation. So now your turn to try. And again, there's a typo here. That y equals shouldn't be there. Your equation in standard form is being given to you as 2x minus 5y equals 0. And the 3 points to try to see if their solutions to the equation are negative 2, 0, negative 10, 6, and 5, 0. So pause the video, come back when you're ready to see the answer. Okay, so I'm going to slide this up just a little bit. When you try all 3 of these, none of them work. No, no, and no. None of them make a true statement when you plug in the first coordinate for x and the second coordinate for y. X and y, x and y. Okay? But does that mean there's no solution? Okay? No, it doesn't. So this doesn't mean there's no solution. We just haven't found one yet. Okay? And that's all we're doing, is we're just trying right now, given possible solutions, given certain points, do these points land on the line? It's kind of like the mathematics version of battleship, right? You place your little ships and then you call out A4, D6, and see, you know, hit, miss, you sunk my battleship. These are all misses. These are not landing on the line that's represented by this equation. Okay, we'll do some more at the top of page 3. See you there.